8 of this because the GoPro kept turning off and whatever. So the presentation yesterday, it was supposed to be a 10-minute presentation. It went on for an hour because of all the questions and etc. etc. But the GoPro lost power and for some reason switched over to time lapse. Go figure. So I have been working on modeling growth for sargassum. The collaboration had 2 main focusing points. One was to forecast drift, which is done by IPCIS. The second, however, is to model and forecast growth along with mass, which is what I was working on. And the second major task was to develop a graphical user interface, which I also was in charge of. The GUI has 4 main modules. The first main module is the basically main menu, which allows the user to switch between the 3 other modules. The first one is the dark blue one, which allows the user to set the initial conditions and create an output file for IPCIS to run. After IPCIS is run, the growth calculation module is used along with the output of the IPCIS, the nutrients file, and the temperature file. So that allows the creation and development of a mass matrix, which the analyzation runs. Interesting. The GoPro just did something weird. Anyways, it didn't switch. I don't care. The first module is still under development. I haven't had time to finish it. The growth module, the user selects 3 files, and then they hit the calculate mass file, and it does everything on the back of the house. The user is not involved in any way other than selecting the files. Now, this is the original formula we're working with from the paper from Brooks, published in 2018. Basically, d-SAR, which is the delta change in the mass of sargassum, over delta time is equal to the mass of sargassum times the function of light times the function of time times the function of nutrients times the max growth rate times the mortality rate times the mass of sargassum. di, which is the delta function of light, is further broken out into 1 over e negative I over ik times the function of age, and then the function of age is broken down into e the negative of age over a ref, which is broken out into the following, which is a huge, well, not a huge mess, but it's a big mess. Substituting the known variables, and t is either 1 or 0 depending on the temperature of the water. It either grows or doesn't grow. The function of n can be turned into the sum of the nutrients. The max sargassum growth u of m is equal to 10%. The mortality rate is equal to 5%, or 0.5, yeah, 5%. And then that. So the glaring issue here is that we do not know negative I or negative age. So, why age is important? Because as sargassum ages, it sinks. As you can see, currently there is a graph on the chart showing that as basically, by 1 year old, there's not very much left. Breaking out the f of I, you can see that as... Okay. So, this is, Crystal came in to grab some stuff. So the left graph that shows the exact same thing. As age increases, the growth rate decreases. The function of light shows as light increases, the growth rate increases, which kind of makes sense. Now, since the age isn't known of the sargassum, I just substituted a 0.75 as a control variable for now, which, after a little bit of rearranging, delta sargassum equals the following. Basically, you just times it by delta t, which is the change of time. And then what ends up happening is we use a mass of 1 for the original mass, because we don't know the original mass because we haven't developed tools yet to detect mass of sargassum via satellites yet. And then every other value afterwards is the mass is equal to the previous mass plus the original or the previous growth rate. Okay. I don't know what's with you. So, the nutrients and the temperature is obtained from marine Copernicus via the EU. Now, the whole idea after the first phase of discovering the growth, which we didn't discover the growth formula, we just wrote it into programming, is that programming is not for everybody. So we developed the GUI, which I showed a little bit earlier, which I'll be demonstrating afterwards. The testing site to test the growth formula was just off of the coast of Nicaragua. 30,000 particles were released virtually into the ocean on October 3rd, 2014 and 17. As you can see on the screen, that in July 23 in 2014, the bulk of the beaching had the study area, they consider it the beaching area. The study area had just started receiving the large amount of sargassum. However, in 2017, it had not yet arrived. I skip forward 120 days or 90 days, and you can see that the sargassum has massively changed in value in the graph on the top left. That it now values anything from 0 to 8, 0 of course being dead. In 2017, however, it shows that the majority of it has already died, and the stuff that is left is off the coast of South Carolina and North Carolina, and changes greatly in value depending on where you look at from the original one. So this is just another snapshot with them side by side with the massive amounts of difference. Now, we'll switch over to the GUI for the actual demonstration so that you can see what is going on. So we'll load it up. Is it going to work, or is it still programmed? We'll find out. So as it loads, blah blah blah, there it goes. So this is the 120-day trial. Of course, everything at the start equals 1. If we switch to the last day, we turn the mass display on, you can see that the sargassum above North Carolina has all died due to it's believed to be temperature changes, because if it's not growing, it dies after time. The sargassum below North Carolina has also, again, greatly changes in value depending on the nutrients that it absorbed. We can manipulate the time and see that 1 month prior to that, on August, that the largest was about 4 mass, and then going back another month, we can see that it's around 1 or 2. So the options on the side are all based on the options based on the side are all dedicated around showing the different masses and the beaching of the original study area, which I just don't feel like setting up because the GoPro shut off again and I'm starting to lose patience. So we're going to skip that. They're just the cumulative graphs. The trajectory, you can click on any two requested points and the software will plot the points with the mass. As you can see, they originally started right next to each other, but they took sort of similar paths, but the particle in number 2 has died within not too long, maybe a couple days, for whatever reason, because all masses are originally set at 1, where in particle 2 it made its way up to North Carolina and stayed at 1. I don't quite know why, but that is what I've been working on. Now there's about 1 million questions afterwards, and I don't really remember all of them. But there was questions between, can I tell which of the 3 sargasms I'm looking at? Which the answer is no. It's just based off of user input. It includes surface currents, nutrients. The nutrients are provided by the EU. I think that's about it for the presentation. Now I have to try to figure out what's wrong with the GoPro because it's shut off 3 times so far. Maybe it's just picking something up that it doesn't like. I don't know. But that's what I've been working on. We leave tomorrow for Lyon, and we're going to go see some lights. And I honestly want to take holiday because I'm tired and I have been working on papers. I'm currently working on this paper and I'm at page 9. I got 3 more pages to write. Hopefully I can make it.